I was nervous before I started. Now I'm told that this earpiece costs €700, so I'm even more nervous. So I'm going to talk about getting your working code to be more robust, and it's sort of aimed towards more at people coming out of beginner, heading into intermediate, as opposed to an advanced talk. So that's where I'm pitching it. So, thanks. Right, I'm off. Now, I do want to just publicly thank, I want to thank Python Ireland and the Python Software Foundation because they sponsored a number of my students' attendance at this conference. Also, Scurry paid for a couple of tickets as well. And I wanted to publicly thank those two. It's a great introduction to a Python, or to a program community in a country to be given free tickets to a conference of this quality. So thanks very much to those people for doing that. I just wanted to make sure that I said that before I did anything else. So Python is great, and when it comes to knocking something together, that's why we love it. You can, in a couple of lines of code, you can do something really useful, and you can produce something pretty quickly. And generally what happens, unless you're setting out from the start to build something really well, you put something together, knock something together, use it, and then you throw it away. And then you come back the next time and you do the same thing all over again. And that generally works quite well. But when you knock together a system, and that system stays around, you use it, it tends to exhibit some characteristics. Your users are you, because you might be your user of this system, start to depend on it, and your small system starts to grow. So it starts to get, from a small system, starts to get bigger. And you have other things that you have to worry about. You have to worry about robustness. So just having it working isn't enough anymore. You have to make sure that it works well and that it's robust. So what do I mean by robust? So I wasn't sure, so I asked my Mac, because it has a little dictionary thing jobby on it, and it came back, and this is the definition that it gave me. It said, robust, the quality or condition of being strong and in good condition, the overall robustness of national and international financial systems. Bad example. The ability to withstand or overcome adverse conditions or rigorous testing. We can examine the robustness of the results. So when a computer person looks at that, this is the word that they home in on. They see that one and they say, aha, I can do that. I can do testing. Right? So if we add tests, do we improve robustness? That's a question we need to ask ourselves. Adding tests to any code base can't hurt because some tests are better than no tests, but tests are primarily concerned with correctness. You want to know, is something correct, as opposed to, is it robust? I think the two things are different. Okay, so if we write tests to ensure, and the tests that we write, we tend to do it before we actually deploy it or before we run it. We write a little function, we then write a test to check that function, the test passes, the function must be okay, and then we move on. But we haven't actually deployed that function with any system and any sort of larger system. So it's all before runtime, which is what correctness is all about, whereas I think robustness is within runtime. So here we go. I've tested this rope to destruction. What can possibly go wrong? He can spend all day testing that rope. God help him if the branch breaks. Right? He'll be single among a whole pile of other things. Right? That's the end of that. So even if your code is correct, it may not be robust. So I typed that into the Python REPL, and it came back and said true. Right? So it must be. Because Python never lies, okay? So there's what we really should have looked at instead of the word testing. The ability to withstand or overcome adverse conditions, okay? So it's what do we do when things go wrong? So that, believe it or not, was the introduction. Here's the talk's plan. I'm going to show you some code that's working. I'm going to run a little tiny system that I have. Right? This is either going to be an absolute brilliant talk or it's going to be a complete disaster because I'm going to run some stuff live and I'm going to change it and fiddle with it live. So I'm going to do that. Then we're going to look at the code. I'll examine the code. There's not an awful lot. As you'll see, it's about if I shrink the font, I can make it all fit on one slide. But we'll look at it in a little more detail. Then I'll show you what can go wrong, and then I'll show you how we can fix it and how we can improve our robustness. Right? So that's the plan for the next 20 minutes or so, okay? This is the talk's inspiration, which last year when I was here, I said, I'm still in the middle of writing this book, and I hope it'll finish soon, and blah, blah, blah. It went to the printers yesterday. Thank God. Thank you. It only took me 4 years. The first edition published in November 2010. This one's going to publish. It'll be available in print in about 3 weeks. It'll be available as a final they have this release version or sort of early release version on the website at the moment. The real one will be there the end of next week. I kept the cover, because I thought that was important. And out of the 500 and so pages from the first edition, only 2 made it into this edition. It's a completely new book. It covers a lot of the same ground, but and it takes some stuff out that was a mistake in the first one. And I'm hoping that people will enjoy it. So that's out. That's where this material that you're about to see comes from some of the chapters in the book. Okay. And if you're interested in actually owning your own copy, I have discount codes both for the ebook and for the print book, and you can talk to me later. I have little bits and pieces that I can give you for that. So this is what the system is actually going to look at. It's a little web application. It's not too exciting. It's designed to be a demonstration technology. What it does is it lets you type in a phrase, it lets you type in some letters, and then it comes back and tells you if the letters are in the phrase. It's almost too exciting, right? And what I'm going to do is I'm actually going to demo it to you so you can see it working. This is where things might get a little hairy. So let me find the code first and start it up. It's a little Flask application. So I'm going to run Flask with Python 3, of course. People weren't expecting anything else from me, were they? And there is it running in for real this time. So when I do something like life, the universe, and everything, and I say Marvin, and I say do it, what it does is it goes away and it does some bit of processing, basically turns them into sets and does an intersection. It's not too exciting what's happening in the background, and gives you back the set of letters. So again, I told you it wasn't exciting. It really isn't that exciting. And what it also does in the background, I'm going to open up another window here, and I'll make it so that we can all see it, and I'll go into, in my machine it's MariaDB, but MySQL. Oh. And thank God I remembered the password. And what it does is it logs that information, and I'll actually just shrink that a little bit so that we can see it. The information that I entered gets logged into my little database. So there is the one that we've just done, which was today, and that's what we typed in. There's where the address, there's where the request came from, there's which browser I was using, and there was my results. So the information that I enter into my little application makes it into a database, and because I thought, well, that's kind of cool, but it's a pain to have to go into MySQL to have a look at that information. I also have another little URL which does it. Oh, look, isn't that beautiful? Look, it actually shows you the information on a Flask web page. So it's pretty straightforward, pretty simple, and it works. So back to my talk. So that's running away in the background. Let's get all my key combinations right. A demo working code just did that. And it works, and here is the actual code that makes up that application. So it's a Flask app. So we're pulling in Flask, we're pulling in render template and request, so standard machinery. I have a little function called search for letters. I'm not going to show it to you. It's just a set intersection. I have it in a module called vsearch. I also have a context manager which lets me talk to my MySQL database in a relatively straightforward way. I will show you that code. So I pulled those in. I create a new Flask app. I then create a dictionary of information about the connection to my database. So it's got a host, a user, a password, and a database. Pretty standard stuff. That goes into the app's config. I have my default route, which is either slash or slash entry. All it does is render the entry HTML and shows me that initial form. So again, nothing really too exciting going on there. When you do a search, the entry form connects up to this code. What it does is up here, it pulls out the phrase and letters from the form. It then decides what the title is. It then sends that phrase and letters into the search for letters thing. So it works out what the results are. It logs the information. Log request is the piece of code that takes the information that was sent to you from the user, as well as the results, and puts it into the database. That's what log request does. And then it renders another template with your results. And we saw that as well. We saw the results when we clicked on the do it button. Again, that's pretty straightforward. There's nothing weird or wonderful going on there. Log request is a little bit more involved, but not much, because it uses my absolutely beautiful use database context manager, which lets me talk to MySQL without having to worry about all the details of talking to MySQL. So all I do is, like you can use the with statement with open when you're working with files, you can use database when you're working with databases. So I use database, I connect to the database with all those database credentials that we saw a minute ago, gives me back a cursor, I define my SQL, and I execute it, and it does it. It opens up the connection to the database, sends the information to the database, closes the connection, commits the data, and everything else, does all of that. Again, other than use database, that code's not hard either. And then the view the log one is it goes and gets the information from the database, brings it back, and then sends it to the templating engine, which then renders it on screen. So again, I'm using the use database context manager again, and I'm then sort of building the page. And of course, I have my standard dunder name equals dunder main at the bottom there, so that my code can run both locally and when I deploy it on Python anywhere, which is what I tend to do with my applications. And as I said, it all works. There is the code squished onto one screen. So just to sort of show you that it's not an awful lot of code. I mean, okay, it was 5 slides of code, but when it's sitting in an editor, it's not really that big. But there it is there. And of course, it's all written in Python 3. The DBCM module, there it is. It abstracts away the details of me talking to MySQL. I'm not going to look at that code in any great detail at this point. Just that, there it is, and there's how you use it. You import DBCM. You then create the context manager with your with statement, and then you execute your SQL, and you go and fetch all. So it just makes it sort of easy. I know that I can use something like SQL Alchemy to do exactly the same thing, but that's sort of more demonstration purposes, and it's in the book, I actually use that as the example of how to build a context manager. So as opposed to saying, go and get SQL Alchemy if you're using SQL. I do say that in the book, but I don't actually show people how to use it, right? So I don't expect anybody else to use it. It's just a demonstration purposes, right? So as I said, it all works. So great, we can deploy it. People can use it, and people can start depending on it, and people are going to ask me for more features, and that's going to start to grow, and people are going to start depending on it, and I really should make sure it works well. Right, so wrong way, there we go. So, but what happens when something goes wrong? So while it works, and you just saw it a minute ago, I proved that it worked because I ran it. So sometimes I say this to my students, I say, how do you know it works? How did you test it? And they say, I ran it. And I was like, how did you test it? And they say, I ran it. And I said, no, how did you test it? And they say, I ran it. And I said, that's not enough. It's not enough to run it. There's other things you have to do. So I'm going to switch off MariaDB. I'm going to see what happens when I switch off MariaDB. When I switch off my database, what happens? Now I have my database running locally on my Macintosh here. I could have it running somewhere else. So I'm going to break out of this again, and I'm going to open up another one, and I'm going to say, because I'm using the Mac, I'm going to say brew, if I can remember the command, services, I think stop MariaDB. I'm getting old, and I have to do that sometimes. There we go. And yes. So it says it takes a while. Hopefully, it'll only take a couple of seconds. Don't do this to me. There we go. MariaDB has successfully stopped. So now I no longer have a database. So if I go back to my website, so this is it running again. So again, sure enough, it comes up, and people say, okay, well, let's have the Hitchhiker's Guide to the Galaxy, and let's search for the letters Douglas, and of course it just is terrible. It's like, oh no, it's crashed. Something has happened, right? It hasn't actually crashed. I mean, that particular rendering bit has broken, but if I come back over here, yes, I'm getting all this scary stuff appearing in the log, but the web application has continued to run. Flask is still up. It's just now that my users are probably not happy with me. And what happens is that, users get upset, surprise, surprise, when stuff like that happens, right? And and it's bad enough when that happens when it's a user. It's really bad when you realize that you're the user and you wrote the crap. And it's like it's your own code that's bad. So, success will come and go, but everyone remembers when you screw up, right? No matter how good you are, they'll always remember the one thing that you did wrong. I don't have time to tell you some stories, but I do have some stories about some of the awful stuff that's happened to me. After, just the tagline is, after 16 years, the payroll people in IT Carlos still don't like me because of what happened once. So what's gone wrong? Well, let's see. Let's go back to that, and it's telling us what has gone wrong. We have got a MySQL connector errors, interface error. So we've got a problem here where we've got some exception has occurred and we're not doing anything with it. And sure enough, it tells us if we come all the way down here, it's not telling me in this case, oh, there it is there. There's my bit of code which caused the issue, which is log request. Log request caused the issue. That's code that I wrote. Oops, it was my fault that this thing's broken. Even though the DBA could have told me he was going to switch off the database, but DBAs, I mean, he didn't, right? Or she didn't, or they didn't, is what I should say, right? But they didn't. So it can happen, right? Even though I'm sort of just doing it to prove a point here. So let me come back. What do I want to look at next? Right, so I have a couple of robustness rules. Here's the first one. And see, I named it after myself. When first thinking about robustness, start by looking at those parts of your code which touch some external resource, as that's the stuff you probably don't control. If you only look at the code that's internal to your system and say, let's make that robust, well, if it's already working, yeah, you can do a whole pile of stuff to it, but it's the stuff that's external to your code. I mean, when you're opening files, if you're opening network connections, if you're talking to the web, if you're using an external API, if you're talking to a database, that's stuff you don't control, and that's stuff that might break. Like, if you can control the stuff, you can probably arrange for it not to break. Right? But if you can't control it, it might break and you have to protect yourself against it. So, what's the fix? Well, it's pretty straightforward what the fix is. We need to handle that exception. Dude or dudette, depending on who you are, right? And we do that by looking at the exception that was raised, which if we come back here, it says, right at the top, it says there was a mysql.connector.errors.interface error is what went wrong. So we say to ourselves, okay, if we can handle that exception, then we can protect ourselves against it, and then if it happens, we can keep going and do something sensible. Right? So we use Python's try statement. So the try statement has got a number of forms. I'm going to show you 4 versions of the try statement. This is the most common one, where you've got a try statement which identifies a chunk of code that you want to protect, and if that code runs okay, everything is fine. If it doesn't run okay, the except suite will run. So this code up here is what you're trying to protect. This code down here is what happens when things go wrong, right? So you can put that log request call in our code inside a try except, and you can look for the MySQL. What was it? mysql.connector.errors.interface error. I wonder where they come up with their naming scheme, but there you go. You can look for that, and you can protect yourself against it, right? There's a second version of the try statement, which includes the else clause, which is an optional clause, and that's what to do when everything's okay in the try suite, but no exception has occurred. So you make it all the way through the code in your try suite, and then what you do is you want something else to happen when that condition holds. So you put that code in your else statement, and it's optional. You don't see it that much in code, but it is there. The else clause does exist in the try statement. The third one is instead of using else, you can use finally. It is also optional, and it is something that you always do. So no matter what happens in the try block, always do this code as the last thing. And you can combine the two of them together. You can say, I want to have an else and a finally. Okay? So you can say, so you've got all your options covered. Most people only really use the first two, but else and finally are there, and they allow you to do some interesting things. And of course, within the Python exception infrastructure, there's a hierarchy of exceptions that you can sort of look for. So in your except clause, you can say except arithmetic error, and it will look for arithmetic errors only, or you can say except mysql.connector, whatever it was, errors.interface error, and it'll only look for that. So you can sort of hone in on what you're doing. Okay, and it's actually pretty straightforward and pretty easy to use, right? Now, people sometimes do weird things, right? People sometimes do really weird things. Now, I know what he's doing with his left hand. I really don't want to know what he's up to with his right, right? So I'm going to do a weird thing with try, except, else, finally. So I'm going to create what's potentially the weirdest generator function ever to sort of show you how these 4 bits fit together. And to do that, I'm going to open up yet another thing. This is why I thought this might end up as a disaster. I'm going to open up a Jupyter notebook. So let me find it. It was in try. So I'm going to open up yet another, and I'm going to say Jupyter. Somebody suggested I get bifocals, and I told them I was old, but not that old. Right, so here we have a Jupyter notebook. Again, I'll make this a little bit bigger, and I'll show you my weird function, which is named after Father Ted. Go on, Ted is the function, and what it does is it tries yield 1, except yield 2, else yield 3, and finally yield 4. So if I say to Python notebook, run that please, what is it? It's shift enter, isn't it? Shift enter, okay. And I run go on Ted. It doesn't actually do anything. It gives me back a generator object, because what the function does is when you've got yield in the function will pause when it sees the yield statement, send the results of the yield to you, and then sort of wait and suspend an animation for you to come back to it. So it allows you to hook that particular function into the, among other things, the for loop. So here's a little bit of code here, which says for t and go on Ted print t. And what it does is it prints 1, 3, and 4. So this code prints 1, 3, and 4. Comes in the first time, yields 1. 1 gets passed back, gets printed by the for loop, and then the function is sitting in suspended animation. The for loop comes back and calls it again, comes back in, realizes that it hasn't raised an exception inside here. So what it does, it said there was no exception raised in here. I'm going to jump to the else block, which will run when no exception has been created in the try block, and then what it does, it prints out 3, and then it suspends its animation again, goes back to the for loop loops back around again, comes back in, and it comes back, and it says, I've got to here, I'm going to keep going, and I have to do this, because that's what the finally clause is. The finally clause will always run, and it prints out 4, and so that's what I've got. I've got 1, 3, and 4. As I said, weird, but it works. Anybody who's doing compiler work with Python, that's probably a nightmare for them to turn that into C code. I would imagine it would be. I mean, I don't think you're definitely not meant to use try and yield in this way, but it let me do it, so I'm going to do it. So I'm going to change it, and what I'm going to do is I'm going to ask it to deliberately raise an exception. So there it is, 1 divided by 0. It's going to raise an exception. And when I now come back to here, if I run it again, what I'm getting this time is that the last time I ran it, I'll just make this a little bit bigger. The last time I ran it, I got 1, 3, 4. Now I'm getting 1, 2, 4, because what happened is this line got to run. We came back in. This generated an exception. It then resulted in this line of code running on the next, this line of code running on the next iteration. Then it came back in. It skipped the else because the try block didn't successfully conclude, so the else will not run. And then it went into the finally, so 1, 2, and 4. Right? So I'm then going to move that exception into the else block, because an exception, just because you're in an else block doesn't mean an exception won't happen. So I've put that in there, and I'm going to run it again, and go on, look at that, I hadn't updated that. That should have been Ted. So this time I do get, so 1 runs, succeeds, it comes back in, it goes into this else block because the try block was successful. It then fails because it's raised an exception. So that's what all this stuff down here is, divide by 0 error. But look, it came back in again, and it did run that finally, even though the exception occurred in the else block. So the finally will always run no matter what happens. Right, which is something that's nice to have if you need it. And then the last one is, well, I'm going to put an exception occurring in the try block, and an exception occurring in the except. And when I run this one, again, I get a problem. Let me see, did that run? Run that, and run that. And again, I'm getting 1 and 4, which means that the first one, it got as far as there, then it died. It didn't go in there because it didn't complete. It went in there and crashed, but it still did the finally, right? So the take-home sort of message from this little detour into try, except, else, finally, is that finally will always run, right? So we can always depend on that. So that's the end of that bit. So let's go back to the talk. Right. So if we look at our web app code, we can say, well, let's take that log request code, and let's check it for that interface error, right? And where do we do this? So, okay, might as well just open up everything here. So I'm going to go in, and I'm going to use a real editor to look at the code. So there we go, and we get VI, which of course after a while. Next time I update my Mac, I'll not be able to use VI because it won't have an escape key. So here's the code. Here's where we call log request. And that's the bit of code that we want to protect. So the question is do we put our try except in there? Well, we probably should. We probably should come up here and say, OK, let's make that a try. Let's indent that. And we put in here except. And we then sort of decide what are we putting in there, and we decide what are we going to do. Right? So what do we put in there? Anybody? The exception that we got when the thing crashed, which is sitting over here in Chrome, isn't it? There it is, that one there. So if we were to take that and do a copy and paste it in there, that would work, right? It's not a trick question. Yes, it would, right? If I remembered that because I'm using MySQL connectors errors, I have to come up here and I have to import the MySQL connector module as well, right? And that, for me, was like there was an alarm bell ringing. It said, what are you doing that for? The reason that you have this DBCM module, which I'm going to open up in my editor as well, the reason I have this DBCM module is that that code abstracts away the fact that I'm using MySQL. So if I was to suddenly change to Postgres, I would only have to change that file to move to Postgres. Whereas if I actually add my exception handling code into, where am I? Into here, I then couple my web app with MySQL. Whereas at the moment it's decoupled. So I really shouldn't do that. I really should not put that big long exception handler string in there, because that couples my code to MySQL, and that might be a bit of an issue. Okay? I'm going to have to go a little bit quicker, so I'm going to quickly finish up here. We're going to run out of time. Okay, so everybody sees the issue there. So what I did, I'm just going to show you the code, is I decided to, in my DBCM code, I created a class called connection error. There it is. And I said it was of type exception, and it has got no code. Well, it does have code, because it inherits all the code from the exception class, which is built into Python. And then in my actual enter code for my use database context manager, I protect the code which connects to the MySQL server. And if that code fails, I catch the MySQL error, and I turn it into a connection error. So I turn it into a generic error, which I then pass back to my code. And what I can do is in my code, instead of saying interface error, I can say, whoops. In here, I can say dbcm.connection, if only I could type, error, and then do something reasonable in here. I'm going to do the one thing that you should never do, which is that. But you could log it in and do whatever you want, and maybe generate a message and whatever the heck you wanted to do, right? So, and all I have to do is come up here, and when I do that, I say, OK, that is a connection error. Right? So that's a pretty simple thing that I've done. I've abstracted away the details of that error in my database code. And this brings me to rule 2, which is when protecting your code from an externally generated exception, don't code a solution which couples you too tightly to the underlying technology. Try and break it out. So I put the exception handling code that was specific to MySQL in my code which handles MySQL, and my web app doesn't have it. Okay, what else can go wrong? The database can be up, but the login details may have changed. You may use the wrong information. And you may also have a problem with your SQL, and I have versions of my DBCM module that handles that. So here is the second version of it. This one adds a credentials error, and what it does is it adds in extra information. It turns out that if you've got a credentials error, you get a programming error from MySQL. So I've added that in, turned it into a credentials error. The other one is that my SQL is broken, and I have a version of DBCM that does that. The plan, if I had had more time, the plan was to actually run this and show it to you running, but it kept changing. I call that an SQL error. It is also a programmer error. So they use the same exception to mean multiple things in MySQL. Thank you very much. But because I've put it into my DBCM module, I can break it out, and I put that into the exit module, because that generally is an exception that will occur when my SQL is running, which is mean that I'm inside my context manager. If there's an exception in there, those details get passed back to my exit routine on my context manager. All the details of this in my book. My God. And Christmas is coming. Just around. So more code. Closing thoughts. By using try to improve the robustness of your database handling code, which interacts with an external resource, we've improved the web app's robustness too. Now we won't have that crying user anymore if the server is down. The other thing that we've done is we've localized our code so that we can change our database if we want to. There are other problems too with this code. And it's, why are we even showing that error to the user? If we have a problem with our login code, a user of our web app shouldn't care, so we really shouldn't be showing them that login information. The login information, when the login breaks, we, the developer, want to know, but our users shouldn't really want to know. So we should never ever have shown them that actual error occurring. Right? That's another story for another day and for another chapter. So God. I see Jerry here is going to go out and get my book as soon as he can. That's it. Thank you.
Thank you, Paul. We're very tight for time. There would be time for one quick question while we get the next speaker up to get ready. Question, anyone?
Down the back. There is a hand down the back.
Yes.
So I have code full of try excepts absolutely everywhere. Is there a higher level kind of abstraction you would suggest put on top of that to make less of a mess?
I don't think so. I think try except is the mechanism that you use to protect your code. Right? So I haven't come across anything. Right? But definitely, like what I did here was I put in a layer which hid the details of MySQL's exception handling from my web app, and I had more generic exceptions. That sort of helps going forward. Okay? All right, thank you, folks. Cheers. See you later.